is a quick audio on the translational process. Remember, translation is where you are going from the messenger RNA to a protein. Translation occurs on the messenger RNA, which acts as a template for the ribosome to bind to in order to make the amino acid sequence. So, if you remember from transcription reads the DNA from the 3' to the 5', but makes the messenger RNA in the 5' to 3' direction. So the 5' end of the RNA, the messenger RNA, is going to come out, and it's going to allow ribosomes to begin to attach. Very quickly, what happens is the 30S subunit sits down on the start codon. So that means that the P site, the groove for the P site on the 30S subunit, will align with the start codon. There's a codon underneath the A site as well. Then, before the 50S subunit is added, you get a transfer RNA charged with a formylated methionine that will align its anticodon to the codon for the start in the P site. Then a 50S subunit will bind to that whole complex and form a full 70S ribosome. So the 50S subunit sits on there. That means it's left the A site empty, but the P site has an amino acid charged transfer RNA sitting in there against the with the anticodon near the codon. The next thing that happens is you have another transfer RNA. Whatever transfer RNA corresponds to the next codon will come in through a groove in the side of the ribosome, click into place, and it puts its amino acid in close proximity to the amino acid in the P site, which in this case would be the start codon or formylated methionine. The peptidyl transferase, which is drawn in a little red squiggly line in there, will allow the peptidyl transferase or transpeptidase to form a peptide bond, which is a dehydration reaction between two amino acid molecules. Then the transfer RNA in the P site is uncharged. The amino acid releases from it. The uncharged transfer RNA is kicked out. The whole thing moves over one, which moves the codon for the third amino acid to be the codon for the second amino acid to be in the P site, and the codon for the third amino acid to be sitting under the A site, which is now devoid or empty of any transfer RNAs. So that's pretty much it. The next thing to happen is a uncharged transfer RNA will come in, land in the A site, click into place, a new peptide bond will form, everything will click down, the uncharged transfer RNA will be kicked out, and then a new transfer RNA can come in and land in the A site. That process will continue until you get to a stop codon, and then the whole ribosome kind of dismantles itself and releases a full string of the messenger RNA and a full protein. So then that ribosome is free to go back and bind to the beginning of this messenger RNA. So in order to control the amount of protein, you can control the lifespan of the messenger RNA and get more and more of the protein being made. Many of the messenger RNAs don't live very long. They disintegrate pretty quickly. So that's one way that you can control the amount of protein that's being made. If you want to extend that, then you put long poly A tails on the end of the messenger RNA, and it increases the lifespan of the messenger RNA. I hope this one helps. I know it's pretty simple. I just drew it on a sheet of paper, but I thought simple was better. You can go online and find 1 million videos showing this process with prettier pictures, but I just wanted something simple to let you know what was happening. If you have specific questions, give me a call.